Suppose we took a half cell, placed an inert platinum electrode covered in porous platinum powder into a 1 molar solution of acid for the hydrogen ions. Let's bubble some pure hydrogen gas over the surface of the electrode, say under standard temperature and pressure. Now this half cell would result in a potential of 0 volts and can be represented by the half cell equation. If we made a zinc half cell and connected it to the hydrogen half cell, measured the voltage, which would give us, say, 0.76 volts, the equation for the cell reaction would be this. Because the zinc has donated its electrons, it has been oxidized, so the half cell is written like so. Now it has an oxidation potential of 0.76 volts. Therefore, as a reduction reaction, we must flip it, which leads to the half reaction, and this means that the zinc has a standard reduction potential of negative 0.76 volts. The negative value means that the zinc ions have less tendency to gain electrons than the hydrogen ions. All elements listed on data sheets that have standard reduction potentials have been measured against the hydrogen half cell under standard conditions, which allows for comparisons. Generally, the more positive the EMF, the more likely it is to be reduced. Obviously, something needs to be oxidized as well, so the reaction listed on your data sheet must be reversed to reflect this. Let's apply this concept. Say, let's determine the cell potential of a nickel-silver couple. Essentially, the potential difference is the overall difference in voltage between the two half cells. Because silver is more likely to be reduced, that is, its voltage is more positive, nickel must be oxidized. So silver is reduced as described by the half reaction, and nickel is oxidized. So we flip its reduction reaction as well as its standard potential, remembering that the negative sign means it has a less tendency to gain electrons. And by adding the two voltages, we have a total of 1.04 volts. The positive sign indicates that it will be a spontaneous forward reaction.